Hi students, so welcome to the class. I am Dr. K.Varada Rajkumar, Associate Professor, Department of CSE, AIML, MLR Institute of Technology, Hyderabad. In this session, we are going to learn how to implement circular queue in C programming. In our previous class, we learned about different operations in circular queue. So now we are going to learn the implementation of the circular queue. So overview of presentation. So first we are going to know how to initialize queue. So next we are going to know how to check whether the queue is empty or not. So after that we are going to implement isFull function. So then we see how to insert an element into queue, that is enqueue function, and dequeue function. So how to delete an element from the queue, and finally we are going to discuss about how to implement display function. Okay, coming to outcome of this lecture, at the end of this lecture you all are implement circular queue using arrays in C programming. Implementation. So circular queue behavior we are going to achieve using some modulo arithmetic. So circular behavior in circular queue is achieved through the use of modulo arithmetic. So modulus operator. Okay. So modulo arithmetic is a mathematical operation that calculates the remainder of a division operation. So modulus operator means this is the percentage symbol. So this is the modulus operator. For example, 5 percentage 6. Now what it returns? It returns the remainder. If you divide 5 with 6, then what is the remainder? 5 is the remainder. So for example 7 percentage 6. Now what is the remainder? 1 is the remainder. 8 percentage 6. What is the remainder? Remainder is 2. Okay. So how we find this remainder in programming languages is by using this modulus operator. Okay. So modulo arithmetic is a mathematical operation that calculates the remainder of a division operation. In the context of circular queue, so modulo arithmetic is used to wrap around the indices when they reach the boundaries of the underlying array. So now how we connect the last element with the first element? The circular queue is, the definition is, we are going to connect the last element with the first element. So how we can connect means by using this modulus arithmetic operator. So how? So let us assume, so this is the array 0, 1, 2, 3. The size is 4. Let us assume the size equals to 4 now. Okay. Now insert the data 10, 20, 30, 40. So this is the rear value. Let us assume I delete one element. So this is the front. Okay. So what is the front value? Front equals to 1 here. So what is the rear value? Rear equals to 3 now. Now I want to insert another number 50. How I insert? I am going to connect this last element with the first element. How? By using some modulo arithmetic. How? We are going to check the rear plus 1. What is the rear here? 3. 3 plus 1, 4. Okay. 4 percentage, what is the size? 4. Equals to front or not? What is the front value? Front value is 1. So 4 percentage 4, 0. 0 equals to 1? No. So we assume that the queue is not empty. There is a space to insert an element. So that is the meaning of this last point. Modulo arithmetic is used to wrap around the indices when they reach the boundaries of the underlying array. So how we know that the queue is full or not? So by using this modulo arithmetic operator. Okay. So this is the condition we write in normal queue. So how we can find is full? The queue is full means we check that rear equals to max size minus 1. That means in this case, so consider this one. What is R here? 3. So rear equals to 3 equals to max size. What is the size? 4. 4 minus 1, 3. 3 equals to 3. Then we are going to display the message the queue is full. But actually there is a space. That is a circular queue. If you connect the last element with the first element, that concept we call as a circular queue. So now how we find that is full means here rare plus 1. So what is the rare here? 3. 3 plus 1, 4. Percentage max size. What is the max size? 4. Equals to front. What is the front here? 1. So 4 percentage 4, 0. 0 equals to 1? No. So the queue is not empty here. Okay, this is the main difference between normal queue and circular queue. So now we see the implementation part. So this is the program. So this is the structure. So this is the initialization of queue here. So what we are going to initialize here? In initialization of queue, we are going to initialize the front value equals to -1 and the rear value equals to -1. So how we know the queue is empty or not? The same condition, front equals to -1, then we assume that the queue is empty. So how we know the queue is full or not? What is the condition? So rear plus 1 percentage max size equals to front. So consider this example. So let us assume size equals to 4, 0, 1, 2, 3. So let us assume the array name is items. Okay, I insert 10, 20, 30, 40. Now this is the rear, this is the front. Identify the values, front equals to 0 and rear equals to 3 now. Now queue is full. How we know that? Rear plus 1. So what is the rear? 3. 3 plus 1, 4. So percentage 4 equals to front equals to 0. So 0 equals to 0, true. So we assume that the queue is full. Consider another case. Now this is the front. Now this is the front. Now I insert 50 here, 60. Now this is the rear. So what is the rear value? 1. What is the front value? 2. Check. So rear plus 1. So rear is 1, 1 plus 1, 2. Percentage max size. Max size is 4. 2 percentage 4, 2 only. 2 equals to front value. Front value is 2. It is true. So we assume that the queue is full. Okay. If we delete one more element now, so this is the front. So this is the front now. Now what is the front value? 3. Now check queue is empty or not. So queue is not empty. How we know that? Rear plus 1. Rear plus 1 means 2. 2 percentage size 4 equals to front. What is the front? 3. So 2 percentage 4, 2 equals to 3, false. So queue is not full. Okay. So this is about is full function. So next function enqueue. The enqueue function purpose is insert an element into queue. So now, so let us assume this is the queue. Size is 4. Size equals to 4. Now let us assume the name of the queue is items. So these are the indexes. Okay. So enqueue, I want to insert an element. Is full, stack is not full here. Initially front equals to -1, rear equals to -1. Here I am calling the is empty and I am going to initialize with front equals to 0. So rear equals to rear plus 1 percentage max size. Here we increment the rear value and we are going to insert the element in rear. So what is the rare here? Minus 1. Minus 1 plus 1 means 0. So in items of 0, we are going to insert the element. For example, 10 is inserted here, 20, 30, 40. Now what is the rare value? 3, let us assume. Now the queue is full. How we know that? So based on the condition what we discussed previously. So what is the condition? Rare plus 1. So 3 plus 1, 4, 4 percentage size, that is 4 percentage 4 is 0 equals to front. Initially I am taking, when we insert the first value, I make the front equals to 0. So 0 equals to 0. So it is full here. Okay. If I delete 10 here, now this is the front value. Let us assume this is the front value. This is the rare. Okay, now again, so rare equals to rare plus 1, 3 plus 1, 4, 4 percentage 4. So 4 percentage 4, 0. So now the rare value again equals to 0. In this place I am going to insert new data. That's it. So this is about insertion. So next function is dequeue. So this is the queue. Size is 4, 0, 1, 2, 3 items. Let us assume 10, 20, 30. So this is the rare and this is the front. So what is the front value? Front value is 0 and rare value equals to 2 now. Now, so before deleting an element, you are going to check is empty function. So is empty means if front equals to minus 1, then we are going to print the queue is empty. Okay, in this case f equals to 0. So we move to else part. Item equals to, so items of front. So item equals to 10 now. Item equals to 10 now. Now, so front equals to rare. If both the front and rare at same place, then the queue is empty. So we reinitialize the front and rare values with the minus 1. Else front equals to front plus 1 percentage max size. After deletion of 40, then we move to here. So that's why here also we are going to perform so modulus arithmetic. So front equals to front plus 1 and modulus of max size. Okay, so this is the case. For example, I insert 10, 20, 30, 40. If I delete 10, then the new element will be inserted here. Now if I delete 20, 30, 40, then I am going to delete 50. So that's why here we are going to perform modulus operation. Okay. So last function, display. In display, we traverse starting from front. So I equals to, we initialize with the front value. So let us assume this is the array 0, 1, 2, 3. So this is the array name items. These are the numbers I inserted 20, 30, 40, 50. So let us assume this is the front value and this is the rare circular queue. Okay. Now we start from, now what is the expected output for this queue? It prints 20, 30, 40, 50. So let us check how it prints. So I equals to q arrow front. So what is the front value? 1 now. Okay. So printf percentage d, so q arrow items of I. So it prints 20 as a output. 20 as a output. So next I equals to I plus 1. So 1 becomes 2 here. 2 percentage max size. What is the max size here? 4. So 2 percentage 4 is 2 only. So I value now become as a 2 now. You can check the condition for termination is, so not equals to rare plus 1. We can traverse up to rare only. So rare plus 1 is, rare is 0, 0 plus 1, 1. Percentage max size is 4, so 1 only. So 2 not equals to 1. Yes, it is true. So again we move to print function. So now what we print? Items of q. What is the I value? 2. So it prints 30. Items of 2 is 30. Next I equals to I plus 1. Now it becomes 3 and 3 not equals to 1. Yes, it is true. So again you are going to print the value 40. Okay. So now I equals to I plus 1. What is I value? 3. 3 plus 1, 4 now. 4 percentage 4, 0. Now 0 is assigned to I value. So I equals to 0 now. While 0, I value is 0, not equals to I percentage 4. Yes, it is 1. 0 not equals to 1. True. So again we are going to print the items of 0. So it prints 50. Next I equals to I plus 1. So 0 plus 1, 1. 1 percentage 4 means 1 only. So I value is 1 now. Here you check, while I value is 1 not equals to, what is the real value? 0 plus 1. So it is 1 percentage 4. 1 not equals to 1, it is false. So that loop will be terminated. So this is the output 20, 30, 40 and 50. Okay. So let us see the main program. Here I try to insert 5 elements. Here I am considering the size is 4. Size as a 4 here. So this is the main program. Here I try to insert 10, 20, 30, 40, 50. But actual size is 4. So when we try to insert this 50, then it returns a message that the queue is full. Now display, it displays 10, 20, 30, 40 as a output. DQ, that means I want to delete some elements. The first one is deleted element is 10. Next I delete one more element, so it returns 20. So there is a space to insert the data. So again I insert 60, 70, 80. 60, 70 is inserted, but 80 is not inserted into queue because queue is full. Now if I display, now what is the content stored in the queue? So pause the video, try to find that. So display means what it displays? 10, 20 is deleted. So display 30, 40, 60, 70. Okay. So 30, 40, 60, 70 is the expected output. Let us execute this program. So this is the output. So 10, 20, 30, 40, 50. So 10 is inserted, 20 is inserted, 30, 40. If I try, here I try to insert 50, so it returns an error message, circular queue is full. Now this is the content, 10, 20, 30, 40. Now here I DQ 2 times. So it displays 10 and 20 as DQ'd elements. Again I insert 60, 70, so inserted. 80 queue is full. Now if I print, the output is 30, 40, 60 and 70. Okay. So this is about circular queue. So coming to summary of today's lecture, a circular queue is a linear data structure where the elements are stored in a circular manner. It overcomes the limitations of linear queue by utilizing modulo arithmetic to wrap around indices. So NQ and DQ operations in circular queues maintain a circular movement of indices. A circular queue is considered full when rare plus 1 percentage max size equals to the front index. In next class we are going to learn about the priority queues. If you have any doubts on this lecture, so place your doubts in the comment section. I will answer all your questions. So thank you.